In the previous video, we looked at algebra or geometrically how to verify that two functions were inverses of one another. In this video, we're going to take a look at how we do that algebraically. And you might recall that what we're going to do is we're going to find f at g at x. That should be equal to g at f at x, and both of those should be equal to x. So basically, we just compose the functions of one another, and then we verify that they simplify to x. That means that they're inverses. So this first example is really easy to see. We know that to add 7 and subtract 7 to a number, that's inverses. Let's start by finding f at g at x. That means I'm going to plug x minus 7 back in for x. That gives me x minus 7 plus 7, which clearly simplifies to x. Now, g at f at x, that means I'm going to take the x plus 7, and I'm going to substitute that back in for x into the x minus 7. So that just becomes now x plus 7 minus 7. 7's cancel, and that's going to be x. And that's good because that's exactly what we need to see. So now we're going to say that since f at g at x is equal to g at f at x, that's at f at x, which is equal to x, f and g are inverses. All right. So that's how we can verify that two functions are inverses of one another. Now, the next examples, they're going to get a little bit more algebraically rigorous, but hopefully not too bad. So now we have this 3 minus 4x and then 3 minus x over 4. So let's see if those are inverses. So we're going to start by finding f at g at x. And so we're going to take this function and plug it back in for x. So we get 3 minus 4 and then 3 minus x over 4. And so we notice the 4's are multiplying and dividing, and so they go away, and we're left with 3 minus the quantity of 3 minus x. We can distribute the negative, and that's going to give us 3 minus 3 plus x. 3's cancel out, and we're left with x, which is good. But now we have to do it the other way. We have to find g at f at x. And so if we do that, that means we're going to substitute 3 minus 4x back in for the x in g. And so that gives us 3 minus the quantity of 3 minus 4x. We're going to divide that by 4. And this one's a little bit easier than the previous. We're going to distribute. And so that's going to be 3 minus 3 plus 4x. So notice we have the double negative. We divide by 4. 3's cancel out. We're left with 4x over 4. 4's cancel out. We are left with x, right? And so, yes, those are indeed inverses of one another. Right? A third example, x cubed plus 1 cube root of x minus 1. F at g at x is the cube root of x minus 1 cubed. So again, just taking this expression, plug it in, plus 1. The cubes cancel out. We have x minus 1 plus 1, and we're left with x. That's good. G at f at x. That's going to be equal to the cube root. Instead of this x, we're going to substitute x cubed plus 1. It's going to be x cubed plus 1 minus 1. Right? And so the positive and negative ones are going to cancel out. We're left with the cube root of x cubed, which is x. Cubes and cube roots undo each other. All right. And so once again, we can see that those functions are indeed inverses of one another because they both simplify to x when evaluating their compositions. All right. Now, this one's a really tough one because of the algebra. All right. And so I might have to refresh the page on this one, but I do want to make sure we do a tougher one just so you can illustrate, or at least I can illustrate the rigor of the algebra for this. So we have this 1 minus, or x minus 1, x plus 5, 5x plus 1, 1 minus x. All right, so what we're going to do is we're going to take this expression and substitute back in for both of the x's. All right, so that's going to give us 5x plus 1 divided by 1 minus x minus 1 divided by 5x plus 1, 1 minus x plus 5. All right, so now to simplify this, what we're going to have to do is get a common denominator. The LCD is going to be 1 minus x in both the numerator and the denominator. All right, so this is going to give us 5x plus 1 divided by 1 minus x. And whenever we change a 1 into a least common denominator, it just becomes the same thing in the numerator and denominator. So that's pretty easy for the numerator so far. Okay, we still have to simplify this a little bit. In the denominator, we have 5x plus 1 over 1 minus x. And since it's a 5, I'm just going to multiply the numerator by 5. Okay, so it's going to be 1 minus x, or 5 times 1 minus x, divided by 1 minus x. All right, now I'm going to go ahead and distribute the 5 in the denominator. So I'm going to rewrite this whole thing just to distribute the 5, but it's okay. So it's going to be 5x plus 1 divided by 1 minus x plus 5 minus 5x over 1 minus x. All right, so now we can start combining like terms in the numerator and denominator. All right, so we have a 5x minus a negative x. Okay, so when we subtract those out, that's going to become a 6x because of the minus minus x. Then we have 1 minus 1, and so those are going to cancel out. So the numerator becomes 6x over 1 minus x. For the denominator, we have 1 plus 5, which is 6. And then we have 5x minus 5x, which is going to cancel. And now you can start to see that this is going to simplify nicely. We're going to multiply by the reciprocal. So we get 6x over 1 minus x times 1 minus x over 6. And so we're left with x, which is good. All right, so we verified at least for the first part. All right, now let's see if we go the other way around, if that works. Okay, and again, that might be a little bit tough, but it's okay. So now what we're going to do is we're going to find, and by the way, this was f at g at x. Okay, and that will work. So now let's find g at f at x. Okay, so now we're going to take x minus 1x plus 5 and plug it in for both of these x's. All right, so we're going to get 5 times the quantity of, instead x plus 1x plus 5, or x minus 1x plus 5. And that's going to be plus 1. And the denominator, 1 minus x. So again, just substituting right here. And remember, x was x minus 1 over x plus 5. All right, now, what we're going to do is distribute the 5 in the numerator. So we have 5x minus 5 over x plus 5 plus 1 divided by 1 minus x minus 1 over x plus 5. We could see that the LCD is going to be x plus 5. And so what we're going to do is just write each of the ones as x plus 5 over x plus 5. All right, so this one actually works out a little bit easier. So we have 5x minus 5 over x plus 5 plus 5x, or I'm sorry, x plus 5 over x plus 5. That's going to be plus x plus 5 over x plus 5. And then we're going to divide that by x plus 5 over x plus 5. All right, so we're just simplifying this 1 minus x minus 1 over x plus 5. All right, so now let's combine like terms. Notice in the numerator, we have a negative and a positive 5. We have 5x and x, so that's going to be 6x. So that becomes 6x over x plus 5. In the denominator, we have, this should be, by the way, this should be x minus 5 over, or I'm sorry, that should be x minus 1, excuse me, that's fine. So that should be x minus 1, so ignore that. We have x minus x, they cancel. We have 5 minus a minus 5, which is 6. And then we have x plus 5. And now you can clearly see, if we multiply by the reciprocal, we get 6x over x plus 5 times x plus 5 over 6, which is going to be 6x over 6, which is just going to be x. All right, so mercifully, they are inverses of one another. And remember, this whole thing right here, this was g at f at x. Okay, so hopefully that helps you to see how we're going to go through and verify inverses, okay? And again, This is a really difficult example, all right? But of course, we just don't want to see all the easy examples. We want to see a little bit tougher ones, especially to refine our algebra before we start going into some of the more difficult topics in the course. So in our next section, what we're going to do is we're just going to find inverse functions given the original function.